Here we have a couple of percent mixture problems that can be solved with a system of linear equations. There is a lot going on in these problems, a lot of pieces of data, and so I think it's really useful to make a chart to help keep them straight, and hopefully that will help us write some equations from with which we can solve the problem. So let's read this first one. It says a scientist mixes water, which contains no salt, with a solution that contains 40% salt. She wants to obtain 240 ounces of a mixture that is 5% salt. Okay, so these are our concentrations. There's one that's 40%. She wants to get to a 5% concentration of salt. And how many ounces of water and how many ounces of 40% salt solution should she use? So in these percent mixture problems, there's amounts and there are concentrations or percentages. So let's make a chart here. So we're going to have the total amounts first. And we've actually got three different things going on here. We've got the water solution. So and we're looking for both of these things, the water and the salt solution. So let's call this X. We've got the salt solution. We'll call that Y. And then we've got the total. So altogether, she wants 240 ounces. So if you add together the amount of water and the amount of salt solution, it's going to be 240. So those are our amounts. Let's look at the concentrations, so the percent of salt. So the first one is water. Well, that's 0% salt. So that's pretty easy. The other one, they're giving it to us, 40% salt. And at the end, we want a 5% salt solution. Okay, so those are our percents. The other thing we're going to put on our chart here is actually the amount of salt. And I'll show you why in a minute. First of all, the amount of salt in the water is still 0% salt, so it's 0. The amount of salt in the Y is going to be 40% times whatever amount of Y we have. So I'm going to write that as 0.4 Y. And then what's the amount of salt in the total? Well, 5% is the concentration we want. So if we multiply 5% or 0.05 times 240, what we would get is 12. So there's actually going to be 12 um, ounces of salt in that solution. From this chart, we can start to make some equations. One is pretty easy. It's from this amount line. The amount of x plus the amount of y is going to equal 240 at the end. So that can be one of our equations. And the other one is down here, the amount of salt in each. So the amount of salt here is 0, so we don't even have to write that, but 0.4 y, that is going to add up to 12 ounces of salt. Now we have two equations. We've got two variables, even though x didn't show up in this second one. We can solve this. And what I'm going to do is just use a graphing calculator again to solve these. You could solve it by substitution here pretty easily, but I'm gonna go ahead and graph it. So x plus y equals 240 is the first one. And let me zoom out a bit. And then the second one is going to be 0.4 y equals 12. And where they cross is right here, and that's at the point 210 comma 30. So x is 210. So the amount of x we need is 210 ounces. The amount of y we need is 30 ounces. So x equals 210 and y equals 30. If you think about this, we've got a pretty strong salt solution, 40%, and we need to dilute it with a lot of water. So we're putting in a lot of water and a moderate amount of the salt solution. Let's try another one like this. Very similar. This one's about salad dressing. It says the chef is going to mix two brands of salad dressing. The first one has 8% vinegar. The second one has 13% vinegar. And the chef wants to make 220 milliliters of something that's 12% vinegar. So let's just go ahead and make the same kind of chart. We're going to have the amounts of the dressings on the first line. And this is just, brand one and brand two, we'll call them, and then the total. So brand 1 and brand 2, we don't know. We're not being told how much of each of the two is going to mix together. That's what we want to find out. So let's just call brand 1 X and brand 2 Y. But the total, chef wants to make 220 milliliters of dressing total. So put 220 there. Now let's do the percent of vinegar. So the first one has 8%, and the second one 13%. And in the end, what we want is 12%. And then we'll put the amount of vinegar. So the amount of vinegar, 8% of X, so that's 0.08 times X, and 13% of Y, so 0.13 times Y. And that is going to add up to whatever 12% of 220 is. So let me punch that in my calculator. And that should be 26.4. So I just calculated this amount of vinegar in our total thing by multiplying 0.12 times 220. So let's pull our equations off of this. The first one we can read off the top. It's X plus Y equals 220. So the amount of X, the amount of Y of each of the two salad dressings is 220 in the end, because that's how much we want to make. And the second equation we can pull off the bottom. So this is 0.08x, the amount of vinegar in that X dressing, plus the amount of vinegar in the Y dressing is going to add up to a total amount of vinegar in the final product of 26.4. So let's go ahead and graph those. So we've got X plus Y is 220, and we've got 0.08x plus 0.13y equals 26.4. All right, and they cross here. So we've got 44 of the first of dressing X and 176 of dressing Y. So X equals 44 and Y equals 176. And if you just look at the problem, dressing Y is 13%, and we're wanting to get to 12%, so you'd probably use more of dressing Y because it's a lot closer to that 12% than dressing X is anyway. So these numbers seem to make sense. So that is how to solve a percent mixture problem using a system of linear equations.